Hello, welcome to the OSU Precollege Program STEM at Home series. My name is Sean Rowe. I am at home, as you can see, in my backyard today. I work for Oregon State University, specifically for Oregon Sea Grant, where I do research on how people learn, and especially how people learn about ocean sciences and the ocean in general. I work at the coast in Newport and in the Corvallis campus. We make exhibits, we make programs for people, and we basically use those to try to understand how to teach better. Today, I'm interested in talking with you about the nature of science. I know that sounds kind of, oh boy, that's like a fun way to spend a Tuesday afternoon, but it really can be. And what's interesting, I think, about this is that, as human beings, sometimes we make decisions based on what we know and what we've experienced in the world. And this is actually really important that we're able to do this. We learn things over the course of our life. We use that to guide our actions and to make decisions and help us. But sometimes we make decisions not based on what we know, but based on what we observe. And what's interesting about science as a set of practices, science as a phenomena, science as something we do in the world, is that very often what we do is make decisions based on what we know or what we think we know. But what we value in science is basing all of our decision making and our ideas and our conclusions on evidence and observation. And so the activity we're going to do today is something you can do easily at home. We can do it together while I'm doing it. I'll give you plenty of time to pause and do the activities I'm doing. Or you can do it at a different time later with some other folks to help you think about the difference between knowing and observing and how one or the other helps you at different points to do different things in the world, and especially when you're doing science. So what we're going to do is start with a few materials, and you've got all these materials in your house. And if you don't have them right handy right now, you can pause me as soon as I give the list and you can go get them and bring them back. The list of materials is actually in the description of the activity on the website as well. First, you're going to need 2 cups. I got these cool scientific looking beakers, but you can use any kind of clear cup, any kind of smallish plastic clear cup or glass clear cup. You're also going to need some water. This water is mixed with salt, and you can make it pretty salty, more salty than you would ever want to drink it or pour it on plants because it might kill them, but pretty salty water. If you're out of salt, you can also use sugar, although it's not quite the same, but it'll be similar. Over here, I've got fresh water. This is just water straight out of the tap. The only important thing is that these 2 cups of water are the same temperature. So my salt water and my fresh water are the same temperature coming out of the tap. And what I did was I poured them out of the tap and let them sit outside for a little bit here before I started. You'll also want to label them because notice you can't really tell the difference between the salt water and the fresh water by sight once the salt melts and dissolves. So I've got labels on the jars, and then I made labels, salt and fresh, to put on my cups when I actually add the water, which we'll do in a minute. The other thing you're going to need is ice. I've got some ice cubes here. It's better if the ice cubes are all the same size and shape, but it's not crucial. It'll work even if they're broken into smaller pieces. It'll just be harder to make the observations. So if you've got all the pieces the same, that's great. If not, choose the biggest pieces to do this activity with. And then you're going to need some food coloring. I've got green, but any color will work. It's better to have the liquid kind than the gel kind, just because the liquid kind drips and drops and does things quicker and faster for us in terms of observation, but the other will work as well, especially if you mix it with a little more water before you add it in. The last thing I would suggest you get is a piece of paper and a pen, because the first step is you're going to write down what you think is going to happen. And here's the question. Will ice, if I drop ice cubes, will it melt faster in fresh water or in salt water? What do you think? Just take a minute and think about it. Will the ice cubes melt faster in a cup of fresh water or in a cup of salt water? And when you think you know the answer, I want you to write it down on your piece of paper. Write down. I'm not going to do anything I wouldn't ask you to do, or ask you to do that. I'm not going to tell you the answer. Great. And once you've committed to an answer, the next thing I want you to do is write down why you think that's the case. Now, this is the tricky part. Why do you think, if you think the ice is going to melt faster in the fresh water, why? If you think the ice is going to melt faster in the salt water, why? What is it that makes you think so? If you're doing this with somebody else, a friend, a family member, somebody else nearby, talk to them about it and see if your answers match up. See if you agree or not. I'll give you just a couple more minutes to do that. And if you're watching this after I filmed it, just pause for a second, write it down. And when you're done, come right back. Okay, once you've committed to an answer, we're going to set up the experiment. What I want you to do is take your 2 kinds of water, fill each of the cups up with the same amount of water. So this is my salt, it's almost full. I just want to leave enough room because I'm going to add a couple of pieces of ice and I don't want it to overflow. And I'm going to label this so I don't forget which one is salt. I'm going to tip my camera down a little bit so you can see it too. And then I'm going to pour the fresh water in the other one to about the same level. And I'm going to label that one as well, fresh water. Okay, once you've got that set up, I want you to take your ice and I want you to carefully select 2 pieces that are pretty much the same size and shape. And I want you to drop them carefully, slowly and carefully into the cup. Now remember your prediction. Maybe you even want to put a piece of some mark on the paper next to the one that you predict is going to melt faster in, just so you remember. Maybe if you don't have labels, you can just write on the piece of paper. Don't write on the table itself, but you can just write too. I'm going to do that because I can't see the labels I made. Salt on this side, fresh on this side. Now, let's observe what's happening. Take a look at your ice cubes. You probably don't see anything yet. That's because it's going to take a few minutes, maybe 5 minutes for the ice to start to really melt. But I want you to observe it as it melts. Don't go away, because the key thing is what's happening right now. What do you see happening? And let's focus not on what you think you're seeing happening, but what you actually see happening. I can see, for instance, that both ice cubes are floating. One is floating a little bit more on the side, the other is floating more on the top. You can actually see my ice cubes floating in there, I think, from the front. I can't tell which one's melting faster right now. They actually look about the same to me. Look at yours and see what you think. It's helpful to move around and look at them. I can look at them from the side. They look pretty much the same, and they're pretty much the same size right now. So what I'm doing right now is I'm actually trying to put aside what I think I know about this activity, what I think I know about the answer to this question. And let me tell you, while we're waiting, the kinds of things that people say. I do this activity with oceanographers. I do this activity with teachers. I do this activity with students of every age, from first grade up through graduate school at the university. And pretty much people always tell me that the ice is going to melt fastest in the salt water. Now, that may or may not be right. We're going to find out. But what's interesting is why they think that. And it's probably some of the same reasons you wrote down. Somebody will say, well, you know, when it snows in some places, they put salt on the road. And the salt's on the road to keep the snow from sticking, to keep the ice from sticking to the road. So what happens is when the salt is making the ice melt faster, making the ice melt. And so I believe the ice cube will melt faster in the salt water than the fresh water. People give all kinds of reasons similar to that, based on either their prior experience and their knowledge about the world we live in, or based on their schooling and their experience. So a lot of people will also tell me things like, well, it's going to melt faster in the salt water, and it's because of the covalent bonds and the blah, 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 molecular structure and the da, 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 da. Great. Did they get the right answer or not is what I'm interested in here. Now let's look at what's going on. What do you think about your ice cubes? My ice cubes, while they're still similar, the one in the freshwater is actually quite a bit smaller now than the one in the saltwater. You probably can't tell by looking at my cups very much, but you might be able to see in the front. This one's a little bit, it's not a big difference, but this one is definitely melting slightly faster. I'm going to give it just another couple of minutes. Look at what you observe. Even write down what you're observing. I'm going to write down some of the things I'm observing right now. So if I'm timing this, I'm about 3 minutes into this, and it looks like originally they were the same. Then initially, I thought maybe the salt was a little bit smaller after a minute or so. But then after I spent all that time talking to you, now I think the fresh is a little bit smaller. In fact, now I can tell that the fresh is definitely smaller, and it seems to be getting smaller faster than the one in the salt water. Now, my ice cubes are the same. They were all made with fresh water right in my freezer here at home. So there's nothing special about the ice cubes. Now, mine is definitely melting faster in the fresh water. It's almost gone. And the saltwater one seems to have stopped shrinking. It's been the same size for a while now, even though I'm breathing over it with hot air and talking all this time. Now, the fresh one is definitely smaller and it's disappearing fast. Sorry, when we do science outside, we also have to do it with the insects. Okay. Once you've got to the point where one of them is almost completely melted and you're pretty sure which one's melting faster, I want you to stop and try to explain what you just observed. Why do you think, in my case, and probably in your case too, the fresh one has melted first? What's your explanation for that? And does it match the explanation you gave at the beginning for what you thought would happen? Usually when people do this, well, I won't say usually, but many times when people do this, they're surprised at what they're observing right now, that the fresh water, ice is melting faster in the fresh water because they just didn't expect that to happen. It goes against what they know about salt and freezing, and salt and freezing temperatures, and salt and roads, salt and snow. All right. Alexis is puzzled. It says right there on one of the comments, it is puzzling, Alexis. Let's take 2 more pieces of ice and let's observe what's happening now. So choose another 2 pieces of ice that are about the same size. And this time put them back in again, just like you did the other 2. The water is going to be colder all the way through now. But this time what I want you to do is take your food coloring and I want you to carefully drop 2 drops of food coloring directly on top of the ice. Right? I'm going to start with the salt water. 1, 2. And then I'm going to go to the fresh water. 1, 2. And now I want you to observe what's happening again. Look at that. What do you see happening? I have a definite problem. Do you know what my problem is? Can you tell? They look exactly the same. Why would that be? What do you think? Is what you're observing match what you think would happen or what predicted would happen or thought would happen? I think there's a problem. Look what's happening. In both cases, the dye is falling straight to the bottom, and mixing at the bottom. What's going on there? I think both these waters are the same. Do you think? What do you think? Do you think this really is salt water and that really is fresh water? Or do I have 2 cups of fresh water? How can we test it? I know, I could get out some more materials and we could actually test that. Let's get another cup. And let's get some more water and let's get some more salt, except somebody misplaced my salt. I'll be right back. You observe and set up another activity. Now we're really doing science. We're going to create a new experiment. Look at this. What do you observe has happened here? These 2 cups have almost mixed completely. Look at the food dye, the green food dye swirling around underneath the ice. And look what at the top. There's a layer that's almost clear at the top. Here's what I'm going to do. I'm going to take my salt water, the one that's labeled salt water, and I'm going to add more salt. In this case, I'm just adding regular canning salt or pickling salt. Any kind of salt will do. Kosher salt, regular iodized salt, and I'm going to stir it just to dissolve it a little bit. What you're going to see at this point, it's a lot of salt. That's right. Somebody says that's a lot of salt. Yeah, because here's what I'm going to do. I'm going to try to create a really salty solution to really make sure that this is salted water and see if the same happens. Because right now, it's me like ice melts fast in fresh water. Salty water. It's so salty you can still see the salt floating around in it. Now, let's let it clear for a second. Do you think, with our new experiment, that the same thing will happen? And were you surprised when I said, oh, this is salt and this is fresh, and I set up the experiment and you saw that there was no difference at all? Did you expect there to be a difference? Maybe there was. Maybe there wasn't supposed to be. We'll never know unless we really try it out. That's also part of observing and making ideas and questions and conclusions based on evidence and observation rather than what we think will happen or expect will happen. I'm going to drop 2 pieces of ice into the salt water, just like we did for the fresh water. This time I've dropped them both at the same time. And instead, this time of watching which one makes faster or slower, I'm going to put the food dye in. And I'm going to put the food dye directly on top of the ice cubes again. And then I want you to observe what happens. Is it the same as what you saw before? Look at that. I believe it's quite different. In fact, to continue experimenting and to make sure that my observations are correct, I'm going to try again. This is the jar that originally said fresh water. And I'm going to refill my cup. And just like over there, I'm going to put 2 ice cubes in again. And I'm going to put in 2 drops of dye, just like I did over there. Now watch, what do you think is going to happen? Claire asked if there's a difference. I can't see the whole question, Claire. If there's a difference in the temperature of the water. Is that what you're asking?
I can chime in here. Claire asks if there is a difference when the salt is completely melted or not.
Oh, that's an excellent question, Claire. And the key is to do an experiment to find out. Try to do it with salt that's just swirling around there, you can see, and try to do it with salt that's already dissolved. Look, you can see it happens pretty fast. This water is cleared up completely. Where's the dye? Look at that compared to this. It looks completely different. If we can explain what's going on by putting our dye in now, our fresh water. Right on the ice cubes. Look at that. Now we have a really interesting thing. This cup is doing exactly what the other 2 did. The dye is streaming down with the cup. And this cup, the dye is staying right at the top. You can see that. Look at that. And if you had 2 cups of really salty water and fresh water earlier, you'd probably see something more like this. Again, did that match what you thought would happen or not? How do you explain what's happening now? We made 3 cups of fresh water. We made 1 cup of salt water. I can't tell which one's moving faster or slower. Maybe I can tell again now with this one, but I can definitely tell that they're acting differently, that the water is acting differently. What's going on in here? The dye is doing what? As the ice cube melts, the dye is following the path of the ice, of the water that's melting off. In the fresh water, that water is sinking straight to the bottom and it's carrying the dye with it. And then it's hitting the bottom and flowing right back up. It's creating this circular pattern in the cup that mixes the water and the dye completely. In the salt water, that's not happening. Does anybody have a good explanation for that? For that simple observation? Secondly, what does this have to do with the rate at which the ice melts? We'll come back to that in just a second. Let's move this one out of the way and put these 2 a little bit closer. I'm going to move them very carefully so I don't jostle them very much. And what I want to do, I actually want to show you this a little bit more closely. At this point, the ice, fresh water, which I added significantly later, is already significantly smaller than the ice in my salt water. That's pretty conclusive evidence to me that the ice in the fresh water is melting faster than the ice in the salt water. And I believe that the green food dye gives us a clue as to why this is happening. I want you to think about that a minute and see what you think that clue might be, that answer might be. If anybody's got it, put it up on the chat real quick. And maybe Emily can read that off to us.
Definitely. Claire says the salt is at the bottom and the ice is at the top. The salt is separating the food coloring when it is cold.
Aha. So the ice, the salt has something to do with keeping the food coloring at the top, and that has something to do with temperature. Anybody else got a different sort of idea or the same idea that they want to reiterate? In fact, I think Claire is exactly right. What I'm observing here is that this ice is actually sitting in a pool of water that's turned green, but that water's not mixing at all with the water beneath. I think what's going on there then is that this is creating a cold layer of icy water at the top that is in fact insulating the ice from melting. And over here, the cold water from the ice as it melts is dropping straight down to the bottom of the cup and staying there, pushing the warmer water up to the top, which is making the ice melt faster. This, in fact, is what we call thermohaline circulation. We're actually getting a really interesting circulation pattern in this cup where the cold water sinks because it's more dense and the warm water rises up as it gets displaced. And this creates an accelerated warming and melting effect for the ice. Whereas over here, the ice is sitting happily in its little pool of cool water at the very top that doesn't sink. Why would that be? I believe it has to do with the fact that the salt water is more dense than the cold ice water. If you want to know more about density, we have another video from a couple of weeks ago where we looked at currents and ocean currents and the forces that drive water around the globe. And we explained a lot more of this and give 3 more examples of activities you can do related to that. If you want to learn more about the work we do in our center, you can also check out my website, which is at a link which Emily can put up in the chat right now, the Pre-Choice Learning Lab. And if you want to know more about the kind of things that scientists do and how observation and knowledge work in scientific thinking, then you should check out the really great Understanding Science website at the California Museum of Paleontology at the University of Berkeley. It's a wonderful resource for teachers, for learners, for families, and it's broken down by age group and by activities that really walks through what it means to think like a scientist and to do science, and to really understand science, not as a simple set of steps we do to understand the world, but as a way of thinking about the world that is collective and individual and complicated and exciting, and really draws on all aspects of ourselves as human beings and the social world we live in to get done. That's all I have for today. If you've got questions, you can email them to pre-college programs, check out the other websites, try this activity at home, try our other activities at home, and start thinking like a scientist. Thanks. Bye-bye.